Hey, Mr. Rosengren, if you're trying to talk to us, we can't hear you.
There we go. Thank you. Appreciate that. So please let me know if there's anything you need. It doesn't have to be me, though. There are a lot of people that are here to help. Okay. So we all grieve differently. So whatever you need. Okay. If you need time, if you need help, we're all here for you. Okay. Any questions that you have about it? Okay. Hopefully you saw, I think it was like Friday and Saturday, I started to drop in some comments on your take home portion of the test to see how you did. Okay, if you haven't seen those yet, just open up Canvas, go to your assignment, like the one that you submitted, and you will see for each question how many points you earned on that one. And know that hopefully today, my fingers are crossed, that today I can get everything else graded, and certainly back to you on Wednesday. Physically, I want to give them back. Yeah.
So, how are you gonna, like, sorry, ooh, okay, I bugged.
Yeah, I got you.
Are you entering them as, like, out of 50 points separately or all together as no 100?
All together, and in the comments on Infinite Campus, I will say which grade was which. Take home 42, in class 50, whatever. Yeah. See, but the comment on your submission for the take home will break down number 10, here's how many, or number 1, here's how many points you got. Number 2, here's how many points you got. Number 3, because the in-class one, you're just going to get back. I'm going to physically hand it back to you so you can kind of see how you did individually. So hopefully I will have those for you Wednesday, because that'll be the last time that you and I see each other in person. At least through December, and maybe longer. Who knows? We don't know what the start of next semester is going to look like. We're not going to make that decision until at the earliest finals week. Honestly, they're not going to make that decision super early. Hopefully we trend in this direction instead of in that one. So, okay, so we'll kind of deal with how the rest of the test went on Wednesday. We'll talk that through. If there's anything you guys want to talk about more individually, then I'd love to sit down with you and do that. Or even it can be virtually too, because you're not going to necessarily know where you lost the points, especially on the take home, because I'm just telling you how many points you got, not where you went wrong. And I'd love to help you with that, okay, so that you can do the best you can, okay? Okay, moving forward. Folks at home, open up today's announcement on Canvas, okay? And down there at the bottom, and folks here too, go to Canvas, because I want you to actually be able to click on that. When you use your phone, it's fine. You can use a laptop too. It's just a quick survey about these remaining 4 weeks. This week, the 2 weeks after Thanksgiving before finals, and then the week of finals. And what I want to kind of hear from you is how do you want those last 4 weeks to go, knowing what we're trying to get to by January, okay? And so let me set some foundation for you before you start working through this. Number one, I have the C60 final, the algebra final, okay? And whether you took the class for credit or not, we all take that same final, okay? That's our final. I know it is, I know what it looks like, and so what I'm doing on this is I'm breaking it down by topic to see what you're comfortable with right now and what you think you need review of before we get there. There's stuff on here that we talked about a little bit. There's stuff that we dove super deep into that should be pretty easy, and there's stuff that we haven't talked about at all. And I just want to figure out how comfortable you feel with each of those, and then I want you to kind of make a choice at the end of how we want to get to the end of December and in what order you want to do that. Okay, so what I'm going to do up at the front here is talk through each one of these, but at the same time give you an example of what the kind of question is asking in case you can't picture it in your mind. So that'll help you make a better decision as to really, and here's the 1 through 5 scale, okay, how comfortable you are with these kind of questions. Okay, not comfortable at all. Like number one, like if you pick a 1 for each one, for each whatever you decide, I need a lot of help and practice to feel ready. Okay, I've never heard of this before. I have no idea what you're talking about. I couldn't answer the question even if you wrote it down, kind of thing. Versus a 5, super ready. Give me the test right now. Give me that question. I want to answer it so I don't forget because I know it so well. I'm never going to know it any better. Okay, or something in between. Okay, it could be 2, a 3, or a 4. Okay, and there's just a bunch of topics on here, and I just go on topic by topic. And I want you to make the choice. 1, I'm super lost. I have no idea what you're talking about. 5, super ready. Give me the question right now. Or something in between for each of these ideas. The first one, solving an equation with the square root. The square root of 2x minus 1 equals 3. Solve it. Get to here. How comfortable are you answering this question? 1, super lost, don't even know how to start. Versus 5, I will tell you these next 3 steps and you will have the answer, no problem, every single time. You decide. Pick 1 through 5. Okay. Second one, finding the equation of a line parallel or perpendicular to a given line. Like, here's a line. Here's a point. Find the equation of the line, let's say, perpendicular to this one that goes through this point. Can you fill in the slope and the y-intercept that would be perpendicular to this line through this point? Choose 1 through 5. Okay, next one. Something we haven't talked about, but something you definitely have done before, I think. Write the equation of a circle given the center and the radius. 1, I don't even know how to start because I don't know what those equations look like. 5, give me the center and the radius. I can write the equation every time. Not solving for it. We don't have to do anything like that. Just, I'm going to give you the center of the radius. You just have to write it down. The question would look like this. There's the center. There's the radius. What's the equation? Okay. Next one. Find the domain of a rational function. How comfortable are you? Basically with that first step, right? I write down a rational function. First thing, what's the domain? Right? Well, factor simplify, but what's the domain, right? 1 through 5. And even though we just did that, that still might be a 4, a 3, or a 2, or a 1 for you. And that's okay. I want you to write down where you're at. Okay. Find the vertex of a quadratic. So I give you, this quadratic. And I say find the vertex. And if it's on this list, it is on the final. Okay. I'm trying to give you as much advance notice of what we need to be able to do. Okay. And stop me if you need me. Okay, next one. Determine the degree of a polynomial in both factored form and standard form. So I give you like 4x to the 5th plus 3x squared plus x minus 2. Or I give you, 2x to the 3rd, x plus 1, x minus 2 to the 4th, x plus 5 squared, something like that. What's the degree? Or what's the degree? Okay. Can you do that? And it's just determined. Not solving, but can you figure out the degree? So 1, I have no idea how to do that. 5, I know the answer to both of them just by looking. Okay, next one. Find the asymptotes of a rational function. Being able to figure out what a vertical asymptote, like where in the function am I looking for vertical asymptotes? And how do I figure out whether it has a horizontal one? And if it does, what is it? Versus, does it have an oblique one? And if so, what is it? Okay, how comfortable are you with that aspect of rational? Finding asymptotes. 1, I have no idea what an asymptote is. 5, I could draw them for you, no problem. Okay. Next one, solving an absolute value equation. We have not done this personally in this class. Okay, and I don't know if you did it last. How comfortable are you solving that equation? If you don't know what the first step is, it's a 1. Okay, if you don't know how to start, you should probably be putting a 1. That's the first step. Okay, because if I put in a 4 on the inside of there, good. If I put in a negative 4 inside, cool. Absolute value is going to give me the positive version. I just kind of solved those 2 separately. If you didn't know that, that's okay. We can figure it out. Okay. Couple more. Find the inverse of a linear function. I give you a function. f of x equals 3x minus 2. You do the work and find the inverse of it. So you know how to start. You know how to solve for it. You know that notation. Okay. Shit. I got one. I know. Feels good to be like, oh, I kind of remember some of this stuff. And even if there's stuff you don't remember, that's okay. We're going to figure out how to do it. Okay. This I doubt many of you, if anybody, knows. I don't know if you did it last year. We skipped it in chapter 1, knowing I wanted to come back to it. Okay. Given two functions, f of x equals x squared, g of x equals x plus 3, evaluate the composition. At a given, an x value, make it up, whatever, okay? I don't know if you've seen this notation. That's like a little O. It's like a weird little dot. It doesn't say fog, but it kind of looks like fog. Okay, so this x would go away, and I would tell you a number, like -2. I'd make it up, right? I'd pick a number. Okay, you plug it into the first one, see what you get. You plug that result into the other one. That's really helpful. Okay, composition to me do a couple things. Okay, but if you don't recognize this notation, you shouldn't put a 5. If you've never seen this before, you shouldn't be putting a 5. If you don't know what composition is, you should probably put a 1. Okay. Okay. Now we start to get into chapter 3 stuff, which is probably what I'm going to do today. I'll see how much I can get done, but finding a domain of a logarithmic function. So I give you a log function. Not some log equation to solve, but an f of x equals log base 2 of x plus 3. There's a function. What's the domain? What x values am I allowed to plug in? If you don't know, put a 1. Okay. Solving an exponential equation, 2 to the x plus 3 equals 8 kind of thing. You know how to do that. Solving a log equation, log base 4 of x minus 2 equals 7. Just making it up. Can you solve that algebraically? Do you know how to kind of switch and get stuff out of the exponents or get them out of the logs and work kind of between the two? Right? Because exponentials and logs are just inverses of each other. And then one more, 1 through 5, and then I have a follow-up question. Okay, given a complex 0 of a function, what's the other one? All right, so I tell you that 3 plus 2i is a complex 0. Can you tell me what the other one is guaranteed to be? Okay. Again, that was pretty recent, so that might ring some bells. Okay. All right. Based on those responses, what I wanted to hear from you, and I'll make the final decision as to what we end up doing, but I had some options as to how these last 4 weeks could go. Okay. The first 3 are pretty similar, and the last 2 are similar to themselves, right? So the first 3 and the last 2 are kind of 2 separate categories. Just depends on how much time you want to do certain things. Okay. So first one, fill in the gaps of the topics we haven't covered yet this week. Like start now, spend the next 4 days doing it. Okay. I will send you a review at the end of this week. The Monday we get back from Thanksgiving, we will review. You'll be at home. I'll be here. We'll review live. Anything you couldn't do over the review, I'll send the review, the solutions, all that good stuff. Okay. Anything you want to talk about, we'll spend our 50 minutes reviewing. I will send you the college algebra CU final that Tuesday. We'll take the final early. We won't take it during finals week. We'll take it the week after Thanksgiving. Multiple choice. I'll send it home. People at home, I just rolled my eyes so hard they went into the back of my head. Okay. We would start trig the next day. We'd start trig on Wednesday. Okay. We would have no final during finals week. We'll just have a little trig stuff to do just to kind of keep you up to date. But I would take some of the pressure off you during finals week by doing the final early. Okay. And of course, we're doing it at home either way. It doesn't matter. Okay. That gets us to trig fastest, which gets us to calc fastest, which gives us the most time second semester to do calculus. Okay, there you go. All right, second option, really similar. The only thing is instead of just reviewing on Monday we get back, we would review Monday, Tuesday. We'd have 2 days of review where I'd talk through some stuff, reteach, go over solutions, whatever you want. We would take the final on Wednesday and start trig on Thursday. Okay, so it's just second option just pushes it 1 more day back by giving you an extra day of review. Okay, third option, we spend a week reviewing for the final, the week we get back. A whole week dedicated to preparing you for like 14 multiple choice questions that you're doing at home with your notes. Okay, that pushes the finals back to the Monday before the week of finals. So you're taking it like a week early rather than 2 weeks early. And we start trig still that Tuesday, and we'd have a regular assignment during finals. Okay, so there are your 3 options for us taking the final early. Okay, getting it done, and not me filling your head with trig before you take a final. It doesn't have any trig on it. You know what I mean? So I like one of those first 3 options because I'm not teaching you stuff and then not testing you on it until months plus later, right? Okay, option number 4. So other good options though. Okay, we fill in the gaps topics we haven't covered this week. So we kind of finished the See You Succeed algebra course part. We start the trig. We'll just start trig for a couple weeks. But we'll stop for review for a day, maybe 2 before the final. And we'll take our final during finals week, whatever that time normally would be. Okay, so we start trig, and we stop and review. But we like, we do the stuff we haven't done, then trig, then review. And then the last one, start trig right now. Don't do any of the fill in the gap stuff that you just talked about. Do trig now, stop a week early, fill in the gap / review, and then take the final. Question?
So, what's the test you do?
Same day.
The same day.
Same day. And of course, I'm flexible. If you have stuff going on a specific day, I can make it work. Seriously, it's 14 multiple choice. I'm just gonna probably like Google form it, really. And you're just gonna answer it. And whatever scratch work you want to send me along with that, I'll make it submissionable on Canvas, so you can get partial credit for stuff. Because if you get the question right, it's just right. If you get it wrong, I'll go back to other work that you did to see if there's partial credit that I can kind of make up some of those points. Okay, so 14 questions, you're looking at like 7 points per question out of 100. Right, so you don't want to just lose all 7 if you could have shown me some work, like, you know, you put -3i minus 2i instead of 3 minus 2i, right? You don't lose all 7 points for that. But if you say, oh, I need to write the complex conjugate, whatever, you write stuff down, I can give you points. So make a choice, and that's it. Whatever you think your option, your best choice is. Basically, final as early as possible. Next one is let's take 1 extra day to review. This is a whole week of review. This is fill in the gaps now. This is trig now. Make a choice. Click submit. Let's see. I'm curious. Now, this is everybody from period 2 and period 4. Okay. Solving equation with square roots, we look okay. Pretty good. Lines, we just need probably a quick little refresher. Okay, circles we haven't done. No big surprise that I need to talk about that. I will definitely do that. Domain of rationals, that's pretty recent, so I'm not surprised to see the skew going that way. Vertex, most of us just want to see it once. Like, oh yeah, okay, now I know what to do. Okay, degree of polynomial, not too bad. Asymptotes, not too bad. Absolute value equations, things we haven't done. I bet if you see 1 or 2, you'll be fine. Inverses, okay, that's an algebra 2 thing. That surprises me a little bit, but I'm guessing that the people that kind of live in this range just need to see it once or twice, and then they'll be fine. Okay, that's what I'm gonna like. You're gonna see a lot of mini lessons over these next few days for sure. Okay, composition, brand new for a lot of people, so I'm not surprised to see that. I will definitely do that. Domain is probably gonna happen today. I'll probably just do domains of logs today, and we'll kind of get into the exponentials and log stuff because I knew that we needed a refresher there. Okay, complex 0. Okay, cool. And then there's our choice. The heavy favorite seems to be kind of reviewing for more time rather than less. And really the other two options, 9 people, 10 people, you get it done now. That's what it sounds like to me. Let's get this final done. Let's get the See You Succeed algebra stuff taken care of before we move on to tricks. I'm in. Let's do it. That sounds good to me. Cool? All right. You can put your devices away. Let's take just this last half hour or so, and I will start chapter 3. That's what I'll do. I'll do an exponential in log. Exponential in log lesson probably today and tomorrow. It'll take me to do that. And then I will start filling in the rest of the gaps, and I'll do it as fast as I can, and then we'll review, and then we'll take it. And so the schedule is certainly not set in stone just yet in terms of how long we review and when this test will be. But it sounds like to me that we'll take the test before finals. It won't take very long. You'll be just fine. Okay, cool. Hopefully that's all right for you guys at home. Let's do it. I'm just going to give you a quick kind of overview of exponentials and logs. Okay, chapter 3. We'll probably start and end at some point this week. Okay, I'm going to keep it pretty short and sweet because I know what the questions look like, and I know you did lots of this last year. And hopefully logarithmic, exponential and logarithmic functions. There's a lot that I could reteach. There's a lot that goes into this. So if this does start to make you just curious about stuff, I'm happy to teach you as much as I can. But my focus right now is preparing you for the final. Okay, so that's what I'm going to do. Okay. Knowing that trig is way more important to me. And then, of course, the calculus. That's what we want to do. Okay. So quick background on just plain old exponential functions. Okay. Expo functions. They could be really simple or they could be really complex. Okay. I'm going to show you just the bare bones of what they all look like. Call it f of x, I guess. Okay. Exponential. That's where the exponent is, right? It's up in the, it's up there. It's where the variable is. So a times b to the x. Okay. That's just pretty much in general, all right? B is your base. That is the base of your exponential function. If that base is bigger than 1, 2 to the x, 3 to the x, 5 to the x, 1.1 to the x, okay? As you plug in larger values of x, that number is just going to get bigger. And what we'll see is a graph that looks like that. We will have exponential growth, which makes sense. And of course, the numbers will tell us how quickly that graph goes up like that. But no matter what, the graph is going to go up, okay? If your base is between 0 and 1, because if it's 1, 1 to the x is just going to stay 1 forever. If it was 0 to the x, it's just going to stay 0 forever. So that doesn't really give us the kind of graph we want. But if we have some base that's, 1/2, 2/3, 0.7, 0.05, whatever, you keep raising that to bigger and bigger values of x, taking small numbers and multiplying them all together, they're just going to get smaller and smaller and smaller and smaller. We're going to have a graph that goes down. We're going to have exponential decay. Okay? Guaranteed. Okay. B cannot be 1, like I said, because 1 to the x forever is just 1, 0 to the x is just 0. And any negatives do not create the kind of path that we want, because negative numbers to odd powers stay negative. Negative numbers to even powers become positive, and so like negative 1 to the x. Negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, negative 1. It's just going to bounce back and forth. And then what do we do with like negative 1 to the 2/3, right? Like all that space in between gets all funky. So there's only 2 things we have to worry about, okay? And really what I want to make sure we understand, because that's the question that's on there, is what can I do to plug numbers in? So we'll just make one up. I don't know, f of x equals 3 times 4 to the x. There's an exponential function. Leading coefficient of 3, base of 4. Exponential growth or exponential decay? 4 is bigger than 1. That's growth. Is there anything holding me back from plugging in numbers for x and getting a y value back? I can plug in positive numbers, negative numbers, decimals, fractions, right? The domain of an exponential function is always all real numbers. Anything. You can plug in anything you want. Okay. There is, however, a restriction for the range. Okay. Every exponential function has a horizontal asymptote at the bottom. Now, this is not me talking about, like, if I made a negative, these graphs would flip upside down. So we're going to keep a positive. But either way, there's going to be a horizontal asymptote, which means there's a beginning to the range, but no end. Right? They're going to go up forever. But they're going to either flatten out on the left or flatten out on the right. Okay? And it comes down to a portion of this that I didn't bother writing down that I'm going to add right now. We can take these graphs and shift them left or right or up or down. Or I can just slide this graph wherever I want it by doing a horizontal change to x, which won't change the horizontal asymptote because I'm just going to take this graph and move it this way. Okay. Horizontal transformations are backwards though, right? They're going kind of the opposite direction. So I'm going to put x minus some constant, so x minus c up there. But that won't change the domain because I'm just sliding the whole graph left and right, but the graph goes on forever anyway. Okay. But I could take the graph and move it up or down. So I could take this whole graph and slide it like up 2 spots or down 3 spots, and the horizontal asymptote is going to go with it. Okay, and that's this at the end, plus d. A, B, C, and D are just numbers. Okay, 1, 2, 5, 1/3, whatever you want. Okay. Now this is actually a horizontal asymptote. This is not like a rational one where, yeah, I can cross it like towards 0. It's just an end behavior. No, this is a line that we do not cross. Okay? These graphs have a bottom to them, but they never actually get there. Okay, like these lines right here are like y equals d. This is y equals d. Now, what's the number I'm adding out here? So y equals 0, right? So this range would go from 0 to infinity. Okay, the range goes from d. I cannot include that number though, because I can't actually get there. I can never actually be 0, you know, in this case. No matter how small this number gets, I'm never actually going to be 0. It'll be really, 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 really small. You know, 4 to the negative 1 millionth, right? Is 1 over 4 to the 1 millionth. So there you go. Hooray, exponential function. Cool. All right, let's do log function. Because that was really what the question was asking, right? It was, what's the domain of a logarithmic function? How do logs and exponential functions relate to each other? Do you remember their relationship?
They're inverses.
They're inverses. Good, nice. I heard it at home too. That's awesome. They're inverses of each other. Okay. Which is why you're going to see what's going to happen here in a second. But let me give you the breakdown for log functions. Okay, I can call it whatever. I'll just call it g of x just to be different. Okay, and it can have all of the same properties. Okay, it could have an a, a b, a c, and a d. And they're going to do really similar things. Okay, a times log base b of x minus c plus d. Same stuff in the same spot. It's just that we have a log with a base instead of a base with an exponent, right? There goes the inverse relationship. These have horizontal asymptotes and no vertical ones. So these are inverses, so switch it. Okay, these graphs have vertical asymptotes but no horizontal. Okay, and they just get reflected along the line y equals x. I'm just going to show you the growth one. The decay one is the same. So there's a log function, and this vertical asymptote would be at x equals. Okay, whatever that number is. Okay, y equals d, because that's the vertical shift. Here's my horizontal shift, x equals c. And so because these are inverses of each other, when we look at comparing domain and range, they're going to switch. Okay, the range will be infinite. There's no horizontal axis. They go down forever. And although they look like they're going to flatten out, they do. I mean, they flatten out big time, but they will keep going up. Slowly, really, really slowly, but they will keep increasing. Okay. The domain, though, has a beginning, and it's just that number. Whatever that is. Okay. We're going to start at C, and we'll go on forever. And so the kinds of questions that they're going to ask, they're just going to give us a function and ask us for the domain. But if you know that the only thing that matters is whatever this number is in here at the beginning, and then it goes on forever, then your life is pretty easy. There's not a lot of work that needs to be done. So let's just try one. Okay, log base 2 of x. Find the domain. Log base 2 of x. That's how we read that out loud, right? Not log 2x, log base 2. So log base b of. Okay, that's how that'll. So it's just whatever number I'm adding over the subtracting inside here. I know that it's going to look like that every single time. I don't have to do any work. I just know that I've got a vertical asymptote where things are going to, just begin just after that and then kind of go on forever. And so what number am I subtracting inside here if there's nothing there? Yeah, 0, nothing. Hooray. And I mean, graph it and look at it, you can see exactly that kind of same notion, that there's a beginning to this graph, but no end. And it looks like it flattens out, but it's going to take forever to delete all this. Yeah, let's just open a new one. To go to decimals and type in logs with bases, you have to come down here to the keyboard, click on functions, miscellaneous. Functions, miscellaneous, log base 2 of x. There it is, right? Goes down right on the y-axis and then just kind of takes off rather slowly up in that direction. Okay, let's do another. Number 2, b of x, log of x plus 3 minus 4, whatever, making it up. I know what my domain is going to be. From something to infinity. Okay, we're not doing any horizontal reflections and flipping this thing backwards or anything like that. We're not going to have a positive value for x right there. So what number, if this is x plus 3, that's the only part that matters. I don't care about the minus 4 out here. That doesn't make a difference. Where are we starting? The opposite. Horizontal transformations are backwards. X plus 3 really means a horizontal shift to the left. All right, slid it over to the left 3 spots. So we've got this x equals -3. We've got this kind of vertical asymptote right there that this thing gets closer and closer and closer to, but never actually gets there. Okay. If I don't write a base, right? I didn't say a base. I just said log of x plus 3. Log without a base. What is that base that I'm not writing? Base 10. Good. Right. And that's that log button on your calculator. Right. The one that's on the front is log base 10. That's called the common logarithm. Okay. Common logs are really nice to be in base 10. Why? How many fingers do we have? How many toes do we have? All right. The whole world revolves around base 10. The whole decimal system. Tenths, hundredths, thousandths, 10,000s. Right. Those are all decimals. Decimals. What is that prefix? Okay. If we had the metric system in this country, it would be perfect, right? That would make a lot more sense. Cool. You got it. Okay, let's just do one more, just to see. C of x 3 times log base 7 of x minus 6 plus 2. 3 times log base 7 of x minus 6 plus 2. What is the domain of that function? That's the only question they're going to ask about log functions. So what should I start with before that? Parentheses. No hard brackets. Okay, can't actually get there. First number? 6. There you go. All right, x minus 6. All right. All the way until forever. Good. Ta-da. That's it. Okay, there's log function. Okay, now there's a log base that I am not sure you've seen before. I don't know if you're familiar with my favorite number of all time. Favorite number that has ever been. And I only really found out about it when I got to calculus. And because it's so helpful to see the calculus that goes with it. Okay. Imagine this. Can I do this in 10 minutes? I think so. Imagine this exponential function. 1 plus 1 over x to the power of x. There's my function, f of x. Okay. Imagine this was what I was looking at. If I plug in numbers for x that are bigger than 0, let's just look at the positive side. Okay. 1 plus a positive number is going to be bigger than 1, right? So we should see growth. It's going to go up. Cool. Believe that? Okay, good. But let's get bigger and bigger and bigger. Let's get really big. But let's do so kind of slowly. Because I want to show you kind of what happens as we do start plugging in bigger and bigger and bigger numbers for x. So I'm going to look at this sequence, but I'm just going to plug in a number right down there. Let's call it 1. Why not? We'll start with a little 1. To the power of 1. Okay. 1 plus 1 is 2 to the first. Okay, 2. Yay, it got bigger. Good. That's supposed to, right? I started at 1 and up I go. All right, I'm going to plug in, let's make x 10 instead of 1. So I'm going to put a 0 there and a 0 down there. So now 1 plus 1 over 10 to the 10th. Like these numbers are always going to match. Okay. So this base used to be 2, and now it's 1.1. This base got smaller. So I'm messing with the base at the same time, which is what makes this kind of an odd looking exponential. It's not quite exponential, like a base to an x. The only thing that's allowed to change is the exponent, right? Here, I'm messing with both. I'm making the base smaller, but the exponent bigger, right? But I'm doing so kind of proportionally, I guess. So 1.1, but to the 10th is bigger than 2 to the first. 2.59, right? It was, let me back it up. Let me do this so you can see the flow. Cool. Bigger. Okay. I'm going to make that exponent even bigger. Let's make it 100 and 100. Did it get bigger? Cool. But look at the jump, right? From 1 to 10, we jumped up like 0.6 almost. But from 1 to 100, I only bumped up like a little bit more than 0.1. So the jump got smaller, right? So I went really far this way, but I didn't make such a big vertical change. Okay. Let's make it 1,000. I went 900 boxes to the right. But look how far up and down I went. 0.015 basically was the only difference. Tiny, 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 tiny. Okay, we did 10, we did 100, we did 1,000. How many zeros is that? 5? Let's do 5 zeros. Well, I mean, this number is really small now, right? This is 0.0001. So this is 1.0001. This is 1.000001. Really close to 1, but look how many times I'm multiplying it together, right? A bunch of times. So it's still getting bigger though, right? It's still getting bigger, but doesn't it seem to be kind of leveling out a little bit? Like the growth is getting smaller and smaller and smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2.7182. Right, there's my only difference. 5 decimal places in is where I find my first difference. All right, one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I didn't, oh, so what? I messed up somewhere. But I don't know where. Ah! Try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's not do so crazy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Things are getting really flat, really, really quickly. I'm going to use this one. I like this one. Okay. What's happening as x gets bigger is this does not keep getting bigger. This is actually trending. And this is what makes it different than a regular exponential function, because you have a base and an exponent that's changing. We're actually trending towards a number. Okay. So you can see. Okay. And that number, when you take this setup, 1 plus 1 over x to the x, and you just let x get bigger and bigger and bigger and bigger, we tend to kind of slow down in our growth. And what we are heading towards is a number that is approximately, and I'm going to give it a name here in a second. I'm going to put that name right here. I'm going to put that number right there. 2.7, 1828, 1828, 45, 90, 45, and then the pattern in the numbers really break down. It's super irrational, but it has a really nice beginning pattern, and you don't have to have that memorized. It's just nice to have it. 2.7, 1828, 1828, 45, 90, 45, blah, 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 blah. The whole thing breaks down from there. It's super irrational. We gave that a name because it is super nice. Okay, I didn't give it a name. A guy by the name there's an R in there, of Leonard Euler. I know it looks like Euler, but it's pronounced Euler. He's German. Okay, this is called Euler's number. Okay. Now, he already had constants for A, B, C, and D, so don't think him too vain by calling this letter, this number, E. It's not E after Euler. It's E because he'd used A, B, C, and D already. Okay. The number E. On your calculator, second division is the number E. Okay. And it's this one. And there are so many ways to break down that number. Second division, press enter, you will see the number E, press enter, 2.718, and as many decimals as your calculator will take. Okay. But it's really this. Okay, 1 plus 1 over x to the x. And there's some really cool breakdowns for that. Now, why am I telling you all this? Well, it's because of this number and its very unique properties that calculus uses E a lot. Okay. When we look at the function e to the x. Okay, and we look at its inverse. So I'll call it, I call it the inverse of f of x, right? Log base e of x. Things happen in ways that otherwise wouldn't. Okay, and I'm going to focus mostly to start on like the graph. You don't have to draw this. I want you to just see and see if you can wrap your heads around it. It's kind of crazy. Some base bigger than 1, so 2.7, right? You're going to go up. And what happens with this function? Okay, I'm going to do my best to do this in a couple minutes. Okay, so here's e to the x. Okay, here I am at 0. What's that number right there? If I'm plugging in 0, what's anything to the 0 power? Okay, cool. But that's e to the 0, right? That's where that came from. Okay. Okay, now this is not to scale. I'm just sketching it. So what happens at 1? Plug in 1. What's that y value right there if you plug in 1? Which is cool, e. It's just whatever e is, right? Okay, go to like 2. So okay, 2 to the second power, or e to the second power. Some irrational number squared. What's the best way to write down e squared? Probably to be perfect. E squared, right? Like there's like, you know, the square root of 7. The best way to write that? Square root of 7, right? Whatever that irrational number is. And that just keeps going, right? So we've got the value of this graph is always e to the x, right? Whatever point, whatever y value you're at, it's going to be e to whatever that x value is. Okay, that's not the interesting part. That's super obvious. Okay, here's the crazy part. Okay, here's the calc A part of this. Okay, pick a point and stop. Wherever you want on this function. And draw the line that is tangent to the function at that spot. So you draw the straight line that only intersects the function right there at that spot. Okay? The slope of that tangent line, so this is the calc A stuff that we're going to get to. This is the only function, the only one in the whole world that has this property. The slope of the tangent line is the same as the value of the function at that spot. If that's not enough to blow your mind, drop a perpendicular down and measure the infinite area under that curve. So the area underneath the curve, above the x-axis and to the left of that perpendicular line, this will be calc B. The area under the curve, 5, 4, 3, 2, what do you think? So this infinite area from when x equals 2 on down, that goes to negative infinity, all of this area is e squared. Guaranteed. That's the only function that does both. The value, the slope of the tangent line, and the area under the curve. Okay. Log base e is called the natural logarithm. This is the natural exponential because of all its properties. So we call it logarithma naturale, natural logarithm. So I'm not going to call it log base e. I'm going to call it ln. Okay. The common log is that log button. Look right underneath it on your calculator. Noel, what does it say? Find the log button on the left. Right underneath it, ln. It's okay because it's written like this. It has an L like that, so it's hard to tell. I'm going to script mine, but just know that these two are the same. Okay, log base e and ln. Cool. We'll talk more about that tomorrow. Tomorrow, new stuff. Okay, so log in live from home. You folks at home, I will see you live in here tomorrow. No homework. See you tomorrow. Thanks, everybody. You're welcome. A lot of writing. Sorry. I know.
I just like